Okay, welcome back. This is a video over 3-6 notes, and this is motion. What I want to talk about real quick is, problems, something in 9 through 14. We're going to do problem number 10 out of that, and we've got quite a bit of, things that we have to do. We've got 5 things to do. So we have this position function, okay? And the first thing I want to talk about is that this is a number line. I'm going to put 0. And what you have here is you have this little thing that we'll call a particle. Okay? And so you have a particle, okay, a particle that moves either to the right or to the left on this number line. Okay? And so we can move to the right, we can move to the left on that number line. And so what I want to talk about real quick to identify what's happening here, if the velocity v of t is positive, meaning it's greater than 0, then it's moving to the right. Okay, if my velocity, which is v of t, is negative, which means it's less than 0, then we're moving to the left. Okay, so I do want to clarify that before we start anything. There's going to be a lot of problems like this, where you've got this particle moving along an axis. And this is just a very, very, standard Calc 1 problem, okay? And so the first thing it wants us to do in Part A is graph the position function, okay? Okay, so there's my graph for Part A, graph the position function. So that's the graph. Now, I do want to note that our domain is restricted between 0 and 5. Okay, that's why the graph stops here at t equals 0 and at t equals 5. Okay, now let's go ahead and calculate the velocity function, which is just going to be the derivative of my position function. So I'm going to come in here and I'm going to write f prime of t, which is equal to my velocity v of t, and that's going to be negative 2t plus 4, okay? Now, I'm going to go ahead and graph that over here on the same graph that I had for Part A. So I am going to put in here that this is Part A, okay? And I'm going to graph my velocity function, which is negative 2t plus 4, all right? So I'm going to come over here, and I'm going to plot a point at 4, okay? Negative 2t over that interval, so I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and then down 2 over 1. Okay, and so I'm going to connect those dots here. All right, and that is my v of t. Okay, the first one, the parabola, that's f of t. Okay, and then I'm going to, all right, is that what it wanted me to do? Okay, find or graph the velocity function. Okay, then it asks, when is the object stationary, when is it moving to the right, and when is it moving left? So what I want to do here in Part B, and I can just tell by the graph, okay, when v of t is positive, when my derivative is positive, meaning when it's above the x-axis, it's moving to the right. So we're moving to the right when v of t is greater than 0, okay, and that's over the interval between 0 and 2, okay? We're moving left when v of t is less than 0, when v of t is negative, and that's down here, and that's between 2 and 5, so we're negative down here, okay, we're below the x-axis. So that's between 2 and 5, okay? And then the question asks, when is it stationary, okay? And we're stationary, all right, we are stationary when v of t is equal to 0, okay? And where is that, okay? And that's just right here at 2. Okay, so that's when t equals 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. 2. Okay, so that's that for part B. Okay, let's take a look at part C. Okay, part C asks, determine the velocity and acceleration of the object at t equals 1. Okay, so I'm going to go ahead and put part C right here. Okay, and it wants to know what's the velocity and acceleration at time equals 1. So my velocity function v of t is equal to negative 2t plus 4. Okay, and if I wanted to calculate my acceleration function, okay, I would just take the derivative of my velocity, and that's just going to give me negative 2. Okay, so it wants me to find my velocity at 1, so I'm going to plug in 1, so I get negative 2 times 1 plus 4, which gives me negative 2 plus 4, which just gives me 2. Okay, and then my acceleration at 1 is equal to just negative 2. All right, so here's my velocity, and here's my acceleration at 1. Okay, let's take a look at part D. Okay. Okay, part D is asking, determine the acceleration of the object when its velocity is 0. Okay, so I know that the velocity is 0 at time equals 2. Okay, at t equals 2. And so what I want to do for part D is, I'm going to come over here, and it wants me to find the acceleration, so part D. Okay, so it wants me to find acceleration when v of t equals 0. Okay, v of t equals 0, so at t equals 2. So I want to find a of 2. Okay, now my function for acceleration is just a of t equals negative 2. Okay, so I know that a of t, my acceleration, is equal to negative 2. And so I'm going to plug in 2 into that. And so if I plug in 2, I'm just going to also get negative 2. Okay, that is the bell for lunch. I'm not going to eat lunch. Lunch has been canceled due to lack of hustle. Okay, all right, let's take a look at part E. Okay, and part E says, on what intervals is the speed increasing? Okay, so I do want to talk about speed real quick, okay, before we do anything. And I want to say over here in part E, okay, that speed is increasing when velocity, when v of t and a of t have the same sign. Okay, and we'll talk about that in length in class, but speed is increasing when the velocity and acceleration have the same sign. Okay, so I want to take a look at our graph real quick. I am going to also graph my acceleration function, which is negative 2. Okay, so a of t, okay, is equal to negative 2. All right, and so because of that, because that's negative 2, all right, I'm looking to see where does my red graph, where is that negative, and then where is my acceleration also negative? Okay, acceleration is negative over the whole interval from 0 to 5, but velocity is negative from 2 to 5. Okay, so the object is actually speeding up from 2 to 5. Okay, that's what's happening there between 2 and 5. That's when it's speeding up, because I'm just looking to see where is my acceleration and velocity the same sign. Okay, and by sign I mean where are the y values at. Okay, my y values are negative here, my y values are negative here. So let's write that down, and let's say that that's the interval between 2 and 5. Okay, so I hope you enjoyed this video. I'm going to go ahead and stop it and do another one, but I hope this was helpful for you, and we'll see you in a bit. Thanks. Bye.